I started as a front-end web developer, meaning that everything that comes with it when it comes to management of the software development lifecycle, from requirement engineering to deployment, eventually went under my management. And under the side, I also learned how to deal with some, or on the side, I also learned how to deal with some DevOps topics. And basically, Puppet is one thing for configuration automation that I learned the way how to use and how to manage. Now, I wrote quite a few books on Leanpub, and I also have a few self-published books as well. Let me see the chat in the meantime, because I can see some things coming in. Yeah, thank you for joining. So regarding some of these books, the third book, actually, The Developer's Edge, is going to be the one that I'm going to retire quite soon. It's a software development career book. Fortunately or unfortunately, it has been picked up by a publisher. So this means that it's available for, I think, at most a month and nothing more. As you can see, my main background has been in JavaScript, but I was also equipped with server-side and DevOps knowledge, so that there is a smooth, so that I can deliver smooth operations full stack. From your perspective, I appreciate that some of you may be considering a switch in careers or extending your knowledge in the area of DevOps, and Quick Start will be providing you with some opportunities to learn and practice not only DevOps, but also some other areas of your careers. So we are very much open to that. And this is only a start for a smooth cooperation. Let's jump into the topic itself. So the objectives of the course. So by the end, you will understand why we need configuration management, why it is not enough to just log into a terminal and just deal with certain local configuration of servers. This is quite obvious, by the way, because imagine that in an enterprise environment, we might have hundreds or thousands of servers, or even more. Actually, when I joined a company back in 2013, back then we had 250 something servers already, and it grew continuously. So some tooling is needed for configuration management. Then you will understand two different ways of configuration management in the master agent, under the umbrella of master agent. So one of them is pull-based and the other one is push-based. You will also understand how to organize configuration files so that you can automate basically your configuration as code, and you can maintain this code just as if you wrote software. So this is where my software development background is going to come handy to you, because we're using the exact same principles that we use in software development as well. And given that you might also consider some aspects of developing your career further, or getting certified, or figuring out in the maze of software development of where to move forward, we will identify the next steps in your career and figure out how Puppet and possibly even the certification in Puppet could contribute to that. So if this sounds like a plan, let's get started with lesson 1 out of these 4 lessons that you can see on screen. So we will start with challenges in configuration management. And if we are talking about configuration management, let's see what configuration management entails in general. So it might be that you have different databases. So let's say document databases or relational databases, and you need to configure them, you need to set them up, or even cloud databases. So this is one thing. Besides the data storage, oftentimes there are also assets that we might store in a server environment and not in a database. So these are like images, like other files that could even be large. And oftentimes we just have an asset server for that. That's also something that we need to configure. By the way, any server-related configuration, even Apache, nginx, and so on, are things that we can also configure and need to configure and maintain. Then we have package management. So if you have any experience with basically any operating system, you know that you have installation packages, and in Linux especially you have package managers, like think about apt, think about many others like yum, dpkg, and so on. So these package installations can also be maintained with code. By the way, we're also going to introduce a concept called infrastructure as code. So we're describing the infrastructure and the server configuration as if we wrote some code for a simple program. So this is one concept that's important. Credential management is another topic, because you might not have an automated centralized solution, but you might also have something where you need to revoke access, or you need to give access to certain users in a certain systems and or for certain software. For example, think about Git, and when it comes to maintaining the different user bases, you will need to send out some commands so that you enable or change the credentials, like from developer to master, and this can also be maintained. So there are a lot of things, and these operations are mostly repeated. This means that these repetitive tasks have to be automated, and the main important issue is that you might have servers that have different operating systems under different operating systems. So this might even cause you some trouble in the parameterization or the availability of different package management option, or even configuring Linux and Windows separately. So we want a solution for all these problems. Manual configuration management, it means that you log into the server, for example, with some tool that allows you remote access. And as soon as you SSH into a remote server, for instance, then you do the configuration natively on the operating system of that specific server. Now, the issue is that if you have a non-uniform environment, obviously you need different commands to execute the same processes. Also, in case of a shell script, the main problem is that it is an imperative process. Imperative, it means that you tell the computer how to solve a certain issue. So step one, you, let's say, check if a user already exists. If the user doesn't exist, then you create the user. If the user already exists, then you check something else, let's say, or what kind of access the user has. And in case the access is incorrect, then you update the access level of the user. This is basically a description of how to solve a given problem. And you can also do this with a declarative, in a declarative way. I'm jumping a bit ahead so that you see one of the positive areas of Puppet. The declarative description of the same process is that you ensure that the user is present with whatever credential level, and you just describe the end state. This means that if the user was present, then it's a no operation. If the user was not present, then you create the user. So this is one way to automate these issues. Also, operation system dependent parts. There is one example in my web development background where we have, let's say, a package JSON through which we create some of the configuration of a web application. And in the package JSON as well, we have some scripts areas. And in the scripts, it does matter how you execute your scripts, because on a Windows operating system and on Linux, the description is different. And given that I have conducted hundreds of interviews and also homework assignments back in the days, and even until today, I have received a lot of homework assignments for job applications that I needed to evaluate that assumed a certain operating system for configuration. And in the absence of documentation, I had to figure out myself how to run that application in a different environment. And this is a major issue, actually. And for this reason, here the configuration was very much OS dependent. So we want to go more operating system independent, and we also want to go declarative. This is why we're This is one reason why we're automating the configuration management, and one solution is Puppet that we're talking about quite soon. So one more very critical configuration management issue is when we make a deployment, and if the deployment is wrong, it might happen that the company you're working for loses thousands of dollars or tens of thousands of dollars every minute or even every second in an extreme case. So in this case, rolling back as fast as possible is something that you need to be aware of. And in case of the configuration changes, it might happen that, for example, if you configure your server settings, you might want to roll back the changes as fast as possible with just one operation, and that should also be supported. If you make changes on like 5 servers one by one, and you see a problem, you need to be able to roll back immediately. You don't have time to log into 5 different servers and manually perform the rollback, especially if you have, let's say, 3, 4, 5 servers and you're load balancing in between them, and you need to make all these changes. So for this reason, it's kind of evident that shell scripts themselves don't solve all configuration issues. They are not portable, which means that you cannot take them from one operating system to another, unless the operating systems themselves are limited and you handle the cases, the different cases where the operating systems are still unique. It's still very hard to test, debug, and update, and also extend imperative code, because normally declarative code, where you just tell the computer what to do, not how to do it, is it's easier to maintain. So this is very important. And also, there is a very important concept. I will get back to this concept later. Idempotent or idempotency. This means that if you run the same commands multiple times, the end state is not going to be affected. So ensure that the user is present. It doesn't matter how many times you run it, you're going to get the same result. While the message create user X is not idempotent, because if the user doesn't exist, first you create it, and if you run the same create the user X message or message command, in that case, your result is going to be an error message. But the end state is still going to be the same. At the same time, from the perspective of getting the error message, you might get different results and you might interpret the script differently. So this is very important, that we want scripts that are idempotent. It is possible to use shell scripts to provide this idempotency, but you need to manually describe them, which is something we don't want because we want to save time. Second myth is let's use containers. They are very, very popular nowadays anyway, right? Now, containerization is a great thing on one level. So it can automate a lot of setup issues, and containerization also ensures that you have a uniform environment. Now, the problem with containerization is that it's not a tool for solving configuration management, because with configuration management, what you need is basically to make sure that you can execute changes in the configuration smoothly. And in case of a containerized solution, you're not only responsible for configuring the resource itself, so whatever environment you're creating, but you also have to configure the containers. So it's just you're creating a problem with a different magnitude. And actually, containerized solutions can also be maintained with configuration management tools on some level. Especially that if you are thinking about cloud solutions as well, even some of the configuration management tools are also compatible with configuring some cloud environments on top. So yeah, this is also a myth. Myth number 3 use cloud-based managed services. So I was jumping a bit ahead to cloud-based. These are just abstractions, so serverless, meaning that you're not dealing with terminal and servers and all these configurations. In practice, it's not serverless, it's just an abstraction, and you're still dealing with a similar type of problem. So the conclusion is that we still need configuration management for multiple purposes. You can see all the purposes in here. We might even find some more. So we touched on the diversity of technologies, operating systems, and so on. Idempotency, maintainability of configuration, the ability to roll back, automating repetitive tasks, higher productivity so that you can execute code faster and you can also maintain your configuration faster, and scalability. So I think that we're sold already that configuration management is something important. So this wraps up the first lesson. This is why we need configuration management. Let's move on to the second lesson, and actually you will also see Puppet in action relatively soon in lesson 3. So Puppet is nothing else but a configuration management tool written using the language Ruby. So it's a Ruby-based tool. It's open source. Actually, the open source version of Puppet is open source, and it automates configuration tasks. And I mentioned the infrastructure as code notation before. You will soon see how to maintain configuration management using just simple code. And actually, there is persistence behind it with PostgresQL. So Puppet, these are the main features of Puppet. And let's see why this infrastructure as code solution is so good. Actually, I'm receiving some emails, so let me mute the other computer. That's my cheat sheet, actually. So now you won't get interrupted. So infrastructure as code is, you will see how convenient it is to maintain this solution relatively soon. We distinguish between two primitive, so basically basic building blocks of configuration infrastructure code: resources and attributes. Think of resources as things in general that you want to manage. So users, groups, folders, files, router, service, package, and so on. These are typical resources. And the resources have attributes. Now, these attributes are, for example, that you ensure that the user is present. In case of a package, you can also ensure that the package is present in the system, but in some operating systems, you also need to give the source for the location of the installation package. Especially in Windows, you have to do that most of the time. That you link an MSI or some sort of a package that you have in the configuration. And the documentation contains this basically everything you need to know about built-in resources in Puppet. And the good news is that given that there are thousands of different types of resources available that you could configure, someone has already written the Puppet code for it, and it's available online. Actually, you have access to more than 6,000 different resources online, and you can use the code yourself as a default configuration. You can also modify, obviously, the configuration, but it's maintained as open source, which means that there are many eyes on it, and this gives the reliability of the solution as well. So let's see how we can use Puppet. We can use Puppet in two ways. One is a master agent way, that's the default, and the other one is a standalone way. Both options require the installation of a Puppet client. So there is a Puppet client that executes the configuration updates. But in case of a master agent solution, actually not Puppet client, but Puppet agent, that's the real terminology. But in case of a master agent solution, there is also a Puppet master, so a centralized node that contains everything about the configuration, global configuration state that needs to be propagated to different nodes. It doesn't mean that all the nodes have to be configured in the exact same way. It only means that the master is responsible for sending different nodes, different configurations. And actually you can distinguish on node level, node meaning that agent computer or agent environment. So you can set up what kind of configurations to execute on which node in case you have servers for different purposes. So in case of a master agent, there is a strict protocol which describes the communication between the master and the agents. And this is what we are going to learn relatively soon. In case of a standalone solution, it's mainly used for testing purposes, although I've learned that some companies also use the standalone solution because of its simplicity. But in general, in a corporate environment, it's not advised to use a standalone solution, meaning that you have Puppet agents on environments, on different environments, and you just execute the configuration, and you just maintain the source code in a repository, and you have access to the source code. This is not as optimal from the perspective of maintainability. Now, master agent deployment model. Let's see what it entails in general. The Puppet master has to be a Linux computer. That's very important. It's not possible to install a Puppet master on, for example, a Windows machine, simply because it doesn't exist. However, Windows machines or even any other OS machines can be configured using Puppet because they can act as Puppet agents, and the configuration is done by the agent actually. Master just stores the centralized configuration state. So by default, the agent is responsible for connecting with the master, and it's basically a deployment model that's called a pull-based deployment model. Pull-based means that the agent pulls the information from the master, so the agent initiates. And this initiation is by default once every 30 minutes. So in every 30 minutes, this configuration update happens. And the master and the agent are synchronized so that this communication happens on a secure channel. So before any communication is initiated, a certification process happens that makes sure that they have a dedicated secure channel to so that the communication is secured. So agent receives the Puppet code from the master whenever the agent contacts the master. And after running the Puppet code, the configuration is updated on the agent computer. This is the idea. So in case of the master agent deployment model, the first step from the agent's end, after ensuring that a secure channel communication channel is established, so the agent has a certificate to communicate with the master. So the first step is that the agent sends the master its current state, and this current state is called facts. So these are facts are a set of state attributes that the master can interpret. And the master, once it receives these facts, it creates a set of configuration instructions for the agent to update itself. This can be to install new packages on the agent, for example. Let's say you want to install some time protocol, like a network time protocol or anything along those lines, or you want to install Apache or nginx or something along those lines. This is something that the master sends the agent. And you can even restart the server. You can do a lot of things. So anything that's in the configuration, it can go to the catalog, and the catalog is something that the agent receives and executes. And upon the execution of the change requests, there is a report that the agent sends back to the master. And this report can also be used, or especially this report can be used for purposes of monitoring what changes have been applied and where. So the statistics can be retrieved from the master because it contains the single source of truth of what is going on in the environment with all the different nodes of the network. So that's the deployment model. And this is a pool-based communication. Pool-based means that the agent contacts the master, and both Puppet and Chef does that. So it works on a pool-based. There is another alternative, a push-based configuration, where the master is responsible for pushing the updates. And SaltStack, Ansible can work in a push model. They don't have to because they also have a pool way of dealing with configuration updates. So the communication is initiated by the master in a push-based case. The advantages or disadvantages can be derived with some common sense, actually. So in case of a push-based update, obviously, if there are many different requests in parallel that needs to be executed fast, and you have, let's say, thousands of different nodes in the network, you might run into some short-term trouble. At the same time, for pool, so it's like less scalability. That's the buzzword, actually, that in case anyone asked you why not to go for a push-based solution, it doesn't scale to infinity. And in case of a pool-based solution, the timing can be distributed on some level, but the drawback is that it might happen for a long period of time, depending on the configuration, but per default for up to 30 minutes, the changes are not reflected on the nodes because of the delay of depending on when the agent contacts the master for updates. So that's the idea. I already give you these reasons, so it depends which one to use. So if you want immediate configuration updates, use the push option. With scalability, you might want to use the pool version. And actually, we have the pool way of master agent communication available, so we are going to use the pool version in this introductory course. So how to install the Puppet master software? I'm using the this special, not special, but this apt-get way of installing, but you can substitute your package manager with it. You can use yum, you can use anything in Linux. Remember, you have to use Linux. That's very important because Puppet Master cannot be installed on other operating systems. So you have to install the Puppet server and you have to start the service. So this is important. That it's a relatively straightforward process, and you also have the link and the slides that might be available to you. Actually, you will be able to see the repetition because it's going to be, this course is going to be made available to you online. You will have to have administrator rights, or you have to execute it with the sudo so that you have you're executing it as admins. So this is the way to install it. I'm not going to install it here, especially that this demo computer is a Windows computer, so it's not even possible, and it could take some time as well. Configuration-wise, what you need to pay attention to, it's more or less written in the installation instructions anyway. So you need to make sure that the agent connects to the master on a special port. And I mentioned this NPT, this time synchronization. Now, it's important that whenever you have master-agent communication, the clocks are synchronized. Because if not, there might be some past and future interpretations where you might have some clashes in the computer. So this is what ensures the, in a distributed system clock synchronization is very important in general. And for that, there is a protocol that we can install. On top of that, go to the puppet.conf for the details. It's in your configuration directory. This confdir folder is something that you can retrieve from the Puppet settings with some of the Puppet tools anyway. So this is something that depends on your Linux type. So it might be different in in Ubuntu as in let's say CentOS or whatever else. I think that Puppet is using CentOS in its own virtual machine that is there for training purposes, so for basic training purposes. So they even gave you some tool to learn, actually. Let's see the Puppet agent. There is nothing special in here, so you install Puppet-agent, and you need to start the service as well. You need administrator rights for it. That's on some operating systems, including Linux. And on Windows, you have a file, basically, that you need to run, and then you need to run that service. And then in the terminal, you get, or terminal, what's the command prompt here? In the command prompt, you have the Puppet commands available to you, and you can run Puppet configuration on Windows. I might show this to you relatively soon. So secure communication, I talked about it, that there needs to be a certification process in there. So we're using SSL certificates. So the Puppet master acts as a certification authority. There is a cert utility in Puppet that you can use. And this certification utility is something that it gives a signed certificate to the agents. And whenever the agent sends something, some communication, remember the facts, for instance, the certification information is also there. So secure communication this way is established. And this is the very first communication between the master and the agent, the certification, because without the certificate, the Puppet master is not going to accept anything. So yeah, that's all for the theory, and now we're going to move on to the practical part of the course. So in this second lesson out of 4, we discussed what infrastructure as code is. Without seeing an example, it's relatively complex, but to imagine, but you will see the examples quite soon. It's literally source code that describes the configuration updates. The resources, as we know now, are anything that we can configure, and these resources have attributes. You learn the push and pull models, also the master agent way, which is a production version of Puppet, and also the standalone model, which can be used for testing. Then installing, well, not necessarily configuring, but installing the master and the agent, it was also in lesson 2. So let's move on to lesson 3, declarative configuration management with Puppet. So what is declarative? Declarative is answering the what question in case of describing a problem, and imperative is describing how to solve a problem. So whenever you write code in a programming language like Java, like C#, like sometimes even JavaScript, although JavaScript is a wild card in that, because you can, actually in most languages you can write more or less declarative code with some imperative elements. But these regular programming languages are imperative because you describe the steps, like step 1 you do this, step 2 you do something else, and so on. So you describe how a problem is solved. Declarative code is, there are 2 branches of declarative programming: functional programming and logical programming, so logic programming. Logic programming is very much like theorem proving, and functional programming, it's like you use different functions to describe the end state. So if you wrote any Haskell code, for instance, you might know how to write declarative code in there, where you describe the end state. Think about like this map reduce filter as well as higher order functions, which describes some sort of mapping in which you describe the end result. You can write the same thing in for loops as well, which would be more imperative. So we will use more the declarative approach, although I admit Puppet has some imperative elements as well. So it's important to bear in mind that in case of Puppet, you have the chance to write similarly dirty code as if it was the worst unmaintainable shell script, because Puppet has the power to express loops, if-else branches, and so on. So sequence selection iteration is in there, and if you have sequence selection iteration, you can write imperative code. But in general, we use Puppet to describe the expected outcome and not imperative code. And the underlying Puppet execution mechanism figures out how to solve a given problem that we described. So we already talked about idempotency, so I'm conscious of time. I'm skipping this. Ensure a file is present is an idempotent statement in Puppet terminology. And this means that it doesn't matter how many times we execute it, we will get the same result. And it's important because the end state matters. So finally, some code. This is the syntax of a typical rule. Remember, we have resources and attributes. We have a resource type. There is an identifier that describes what resource we're talking about, and an attribute value correspondence. Now, I'm going to move the mouse cursor to the last comma. You might see that on screen in the absence of other highlighters. Now, look at this comma. This is basically an optional trailing comma. The reason why it's there is that you're definitely not going to miss this comma in case you introduced a third row attribute 3 value 3. And it just saves some mental capacity from the developer's end that you don't have to go to the previous row and add another comma. So this is not a typo. This is something that exists in many languages. In fact, it's even standardized in JavaScript lately in one of the latest ES proposals. So you have this attribute value. One example, now this is the first real Puppet code. Imagine that you have a file and you have some file path and you ensure that the file is present. So this is something that we can do. So let me jump into this code editor. I already created the test.pp file, and let me. Oh, actually, I also have Camtasia open. How bad is that? Anyway, it's already removed. So let me type this in. So file, and we ensure that it's present. I can use single or double quotes, it doesn't matter. And we also have to provide this path to a file. So let's see what we have as folders available, because I moved everything in here. So c/puppet, c Puppet, we need double backslashes in Windows. You can also use single quotes and forward slashes, except in some attribute values where the operating system consumes the code. So therefore, by default in Windows, I'm going to use double backslashes, /puppet/test.txt, for instance. This is going to be the name, and we have to ensure that it is present. Now, what we can do in here is that we have this test.pp, and I'm going to show you how to run this file. So it's puppet apply. This is the basic command, and you give it the file name, and --no op is basically a test run where you just test the syntax in a, actually not validate the syntax, but you emulate. So there is already an error in the test itself. So let me see what I did wrong. This is always the issue with live demos, actually, that something can go wrong. Syntax error, colon, line and column 22. So it's basically this thing in here. And then it's, you also know that we have a freeze box, basically. So this is already an issue. Let me see the file source. Actually, yeah, it's actually in here because we need a comma and not a colon. Sorry, so I was not on line 1 but on line 2 by accident. So this is a bad syntax. Let me rerun the saved changes, and then notice it's compiled. And here you can see what is happening. So it says stage main whatever file in the ensure you need a declaration. You need to make sure that the current value absent should be present. So this means that currently the file is absent, and once we run this test.pp file, it's going to be present. And let's see if this really happens. So once again, you can see that there is no txt file on the left in this total commander. So let me run the test.pp. It's running. It takes some time. It's not a big deal, actually. The changes have been applied, and you can see the test.txt file created. Now, the issue is that the text.txt file is empty so far. Let's see how we can give it some content. So content, typically we have a hello world program. So let me add hello world and the trailing comma, save it. And if we run it with the no op, so which means that we just check what the changes would be if we executed the update, then we would see that the current value, which has some MD5 print, this hash value is going to change to this value, which we don't know what the actual content is going to be, but we can anticipate some content changes. Let's see what happens if we apply the changes. So it's going to run. It's taking some time once more. And after the update is applied, all of a sudden the text hello world appears in the file. So the file size is not updated by this total commander, but it doesn't really matter. You can see that the hello world is already there. So some bytes are already written in the file. And by the way, if we execute it with the no op, in that case, you can see that it's not going to change the contents anymore because the contents are actually correct. So you can see here that applied catalog in minimal time, 0.09 seconds, and there are no changes that need to be executed. So why is it important that we create files? It's very straightforward. We create files because we might need to create some configuration and some other stuff. So this is one example. The other example is NTP. We need to ensure that it's present, or an alias for present is installed. This is good if you have a package manager in Linux, but in Windows systems, you also need to give it the source, because there is also a source element that you need to know where to install this NTP from. And if you install the proper source, in that case, the installation is going to happen and the wizard is going to be launched. Another example, make sure that nginx is running, ensure it is running. And this is basically infrastructure as code. We have these declarations and it's straightforward. Another option is the user Zsolt, ensure that this user is present. So I can execute this actually because this user is present on my computer. So we can also add user and Zsolt, ensure present. And I'm not going to run it. I'm just going to give you the no-op version so that you see that, oh, my internet connection is unstable. This is a problem, actually, for the recording. Hopefully, you can still hear me.
Yeah, we can hear you. We can hear you.
Great,
Yes.
great. This is just a temporary spike, hopefully. Thank you for confirmation. So you can see that no changes are requested, but as soon as I change the username to Zsolt2, for example, then it might ask for some changes. And actually, I can create this user as well in reality. So you can see that the end result is current value is absent and it should be present because of the way how it's how the credentials on my computer are set up. So this is very straightforward. If I created it, in that case, I could delete this new username by writing ensure absent. So the opposite of ensure present is ensure absent. But this is still very straightforward. Let's continue with something more complex. So in case of a file, you can see the ensure present part. You can also set the owner of the file, and you can also give some random content. And so this is all possible. In fact, you don't need to place all the content in here, because you can also invent a templating language. Not invent, like also use a templating language that makes sure that you can write maintainable configurations even with Puppet. That's another example for GitHub, not GitHub, Git configuration, where you need to configure, for instance, the username, the user email. This is a typical configuration change that you can execute, especially if you host, let's say, Git locally. Now, applying the Puppet rules, we have already seen that, how to apply the rules. So you have the sudo puppet apply no op. Actually, one thing that you didn't see is that my command prompt in Windows, I run it as an administrator. So you have to run it as an admin, or use the sudo in Linux, so that you have this, you have the rights to execute a Puppet. And with the no-op, it's just a dry run. It just tells you what to do. And the real update happens when you remove the no-op flag. And actually, what I didn't tell you is that there is also a Puppet parser. So let's see the Puppet parser. Puppet parser validate and test.pp. It validates the syntax. So if I add the error that I made by accident with the colon instead of the comma, and validated the syntax, you would see it before the dry run. And actually, this is the valid way of checking what is going on. So when you have a master agent way of communicating, on the Puppet master, you check the syntax of the Puppet file. And on the Puppet agent, first you dry run it, and then you run it if the dry run succeeds. This is the normal way of executing Puppet updates. And by the way, just so that you know some more Puppet syntax, you can also run a Puppet emulator where this walks you through an 8-step process, actually. And this will make it possible to just see for the first time what Puppet is like. So for example, there is the Puppet resource user root. There are these attributes for the root user. You ensure it's right now it's present. There is a comment in there. There is a home and a password, which is basically some hash of the password. Now cat guess.pp. There's the second part. If you can check what is in there. And basically, you can go through a scenario where each and every step is explained to you. You can read it. You can play around with this emulator. It's like 7 steps. It gives you some experience of what it is like to work with Puppet. So this emulator is something I recommend that you play with. It just takes you 5 minutes to go through it, and you get some more experience. Now, these Puppet resource descriptions are very much like functions or methods inside, let's say, an object-oriented program. And there is a higher level construct called a class. A class can contain internal variables and also rules. So the rules are the same that you saw already, like file, user, and so on. And classes have a class name. Now, if you only have a class and you don't have, let's say, this include statement that's at the bottom, in that case, the problem is that whatever is inside a class is not going to be executed. So for this reason, you just you also have to include the class so that the resource rules are executed. It's very much like the include is very much like instantiating the class and running whatever is in its constructor. So this include instantiation oftentimes happens in declarations of specifying which configuration updates to run on which nodes. So it's important. Nodes are the computers in your network, and for different nodes, you include class C, for instance, and then the configuration is updated that way. This is an example for Postgres config. So you have the PostgresQL config class, which contains a package, a file, and a service. This is a typical pattern in Puppet, actually. So first you make sure that the package is installed. You make sure that the configuration file contains the proper source. So the configuration is correct. And then the service is running and it's enabled. So this is a typical package, file, service, triple. And once you include it, then these three resource rules, the package resource rule, the file resource rule, and the service resource rule are going to be executed. This is the idea. So now you can see a bit more complex type of configuration. It's still code, and it's still very much understandable. We're talking about 14 lines in total. It's not too much. Then the next thing is that you might want to add a dependency, because you don't want to run the service until the package exists and it's installed. So so you require the package rule for the service to be running and enabled. This is one modification. A second modification is that as soon as the configuration is there, you notify. So you can also add the notify attribute. This way you can notify the service. So we have all these options available in Puppet. Now, next thing, selection and iteration. So imagine you have this file declaration. The question is, what if we had 100 files? So not just one file, but 100 files with the same owner. You might not want to duplicate this file 100 times, especially if you wanted to change the owner, you would have to change it 100 times. This is very much analogous with programming principles of writing dry and wet code. So dry means don't repeat yourself. This is what we want. And wet means we enjoy typing. And given that normally it doesn't pay off to enjoy typing, you need to abstract that if you wanted to change the owner of 100 files, you would need to do something. So the first option is that we abstract the owner, which is Zsolt in this case, into a variable. And we still replicate the file 100 times. So this file declaration, we will work on that very soon. But at least now the owner can be changed in one place. So this is important. Notice the absence of the comma in the owner variable declaration. So there is no comma afterwards. If you wrote a comma, the syntax error, so the syntax parser would highlight an error. So this is one option. Now, if you had 100 files and you could place it in an array, so this array structure is inside the files. In that case, you can get rid of the previous 100 file structure. So you can have, instead of these 100 file declarations, you can just have one file declaration. And if it has an array in the identifier part, in that case, it performs iteration automatically. And we ensure that they are files, and we ensure that their owners is whatever owner. So I can actually show this to you in here in the file example. So I'm not going to use the second one anymore. And instead of this one file, I can create multiple test files. So for that, we need a class first. So class file create. And then I'll place this inside. And let's see, we'll have a files variable. And I'll add this files variable in here as an array. Actually, we can tabulate it, and we can place the values in here. I'll create a test1, a test2, and a test3 text file, and we will place the iteration in here. The content is going to be hello world. Let's validate the syntax. Oh, I'm going to show you the part. Let's see what error. I made no errors. Very good. Now run the test with no op, and then we will run it properly as well. So catalog, whatever, applied in 0.06. That's interesting, because if I run it, remember I didn't include the class. This means that, that no changes will be executed. So actually I made an error. Good. So include is needed, file create. So this is this has to happen. Remember this slide somewhere here. So you have to include the class before running it. And if you include it with the no op, you will see right away a different execution, because now actually whatever is inside the file create is going to be executed. So yes, there you go. So you see some changes already. And if you execute the changes, you will see the files created relatively soon. So the tests are going to be executed in here. Yes. And the 3 test files are there with the content hello world. There you go. So that's one update that's worth noting. So I'm saving some time. So file assign problem is already something that we discussed. Puppet factor, it's something that's also available to you. I can also demo it. For example, if I run this factor tool, then I can have access to the configuration, so some variables, that describe the environment, and this puppet factor is going to be available. So let's see. As far as I remember, it's puppet factor. So it's not going to be factor or puppet factor. No, it's like simply factor. And you can see my path, for example. You can see quite a lot of stuff, my CPU, and that the computer has been running for more than 4 days, actually. So I haven't restarted it, which is quite good, actually, because there is some auto restart every week anyway. So I promised some if-else. I'm not going to demo it, but you can check it out on your own computers if you follow this tutorial. So for example, I can define that if we have a variable uptime seconds, with which we can reference to this factor variable. Actually, the uptime seconds is in here in the system uptime seconds. I could even place it in here with uptime underscore seconds, if I'm not mistaken, and this uptime underscore seconds can be executed relatively easily with the terminal. Where is it? Here. So puppet apply test pp. Let's see if I didn't check the syntax this time because I want to save time. Actually, so the content is going to be changed. This is what we expected, and without the no operations, if I execute this, then the uptime seconds are going to be inserted into the files. So changes are being executed, files are going to be written, and here we have the hello world 420,161. My computer has been running for this many seconds. So this is already an update. So let me continue. This you can even add an if-else in this way. Most programming languages have this if-else structure. It's nothing major. So Puppet nodes. I mentioned that there are different computers, and you can identify them with the node name, and you can specify which classes to include. this is how the Puppet configuration is maintained eventually. Manifests are the PP files that we execute. So you have different manifests that even come with Puppet. This is one other thing. So summary, you learned all these syntax options in this lesson. If you go through them a couple of times and you experiment, nothing prevents you. I mean, you can even install it on your own computer, regardless of your operating system. I highly recommend that you take action, actually, and go through some of the examples and some more with some research, because this is how you develop a skill. Just watching a video or this webinar is not going to take you, install the knowledge in your mind like automatically. So last lesson, I'll keep this part very short because it's kind of an obvious lesson, what to do with this knowledge. So read the official documentation. In any DevOps topic, especially DevOps, you need to read a lot. So read the manual, and the other abbreviation is RTFM. Depending on, you can research its abbreviation, what it means. So you need to read a lot because with reading and with applying, so it's like not just read randomly, but rather you have a problem and you research the solution online by reading manuals and documentation. This is how you develop your skills. And if you want to go further, you can be a Puppet certified professional. This means that you take Puppet certification. You don't have to take Puppet course for that. You can, but you don't have to. And the certified professional is something that will be there with you throughout your career. You don't have to renew this certification. However, the certification only ensures that you are certified for a given Puppet version. So this is not transferable to a newer Puppet version. Official documentation is in the docs. Read it. Spaced repetition, it's like from time to time you get some problems, you solve them, and you develop the skill. Straightforward. Puppet Forged, I talked about these 6,000 modules and descriptions that are there. So for example, if you wanted to research what MySQL, PostgresQL, or anything along those lines are, you go to forge.puppet.com, and then in here, let's say you write postgresql, for instance, search, and there it is, PostgreSQL supported. You go in there, click on it, and you can see some Puppet code in there somewhere. So you can see how it can be installed, and basically you can also see quite a lot of documentation in there, and also some source code. So this is now real source code and configuration for this PostgreSQL and Puppet. So yeah, more than 6,000 modules are available. This is the example actually that I searched live. So Puppet Forge, that's one thing. Puppet also has an enterprise version. The 2019 version just came out not too long ago. You can research that as well. And I already talked about the certified professional exam. It's relatively hard actually because you need an 80 to 90% passing score depending on the test they give you. But remember, the harder the certification, the more its value is, because if everyone could get this, it's as if it was a certified Scrum Master with a passing rate of 69%. And if you took the training, then you get the certification because it's an unlimited time type of certification. Then obviously it's devalued, right? So even in that case, I would go for the professional Scrum Master certification. So the fact that this is a hard certification, it means that it's going to be valuable for you. So it's important. There are always two sides of the coin. And as a DevOps professional, you can even research Puppet.com's resources on 2018 DevOps Salary Report. you have a lot of opportunities in DevOps. This is one of the most lucrative type of software engineering professions. If you have the affinity for that, and if you have the interest and motivation, or you can develop the motivation intrinsically, I can highly recommend it. Now, the issue is that if you want remote work, this might not be the option, because a software developer with a programming language might be more inclined to do remote work and find more clients for the long run. But at the same time, I have seen DevOps professionals as well work remotely. It's not a big deal. It might just be in the minds of the stakeholders who are not technical people that remote work for DevOps might be a bit harder, or I might be wrong based on limited sample size that I saw in the industry. So this can also be a possibility. So summary, this is what you learned, like why configuration management is important, how Puppet solves it, what the basic syntax of Puppet is, and then what you can do with it from the perspective of your career. If you have any questions, let me know. Thank you for staying with me for 10 minutes extra, actually. So conscious
No
of
worries.
that. Let me know if I can help you with anything.
Okay, thank you, Zsolt, for the session. If any of you guys have any questions later on and not now, you can always email to marketing@quickstart.com and we'll get them answered. Zsolt, thank you very much. It was a wonderful session and looking forward to see you. I think it's a week from now, the next session. It's very, very close by. We'll see you
Actually,
very soon.
in 2 days, but it's web development. It's another topic.
Oh, yeah.
Yeah.
Okay, so see you then.
See
Okay,
you.
bye,
Take care.
everyone.
Thank you very much.
Thank you, everyone. Bye.